All right, in number 7 and number 8, we want to use our summation formulas, or sigma. So just as a reminder what these are, this is the formula you're plugging into. This is the first number you're plugging in, and that's the last number you're plugging in. And then this is the Greek letter sigma. That means add them all up. Okay, so we'll walk you through that. Get rid of those. So we're going to start with that first number. We're going to plug in 3. Okay, so what we do is we're going to do 2 times 3 minus 5, which gives us 1. Then we're going to plug in the next number that comes after 3, which happens to be 4. So we're going to do 2 times 4 minus 5, which gives us 3. Then we're going to plug in 5. And then we're going to plug in 6. 12 minus 7, sorry. Then we're going to plug in 7. Then we're going to plug in 8. We're just going to keep doing this until we get to the number 9. That tells us where to stop. Well, that was supposed to be an 11. Okay, so that's what we get. 1, 3, 5, 7, 9, 11, 13. Okay, now another way, that's kind of writing them vertically because I knew I didn't have a lot of space. And then the sigma means we are going to add those numbers all up, which I'm really running out of space. And when we add those up, I'm going to start from the bottom here. 24, 33, 40, 49, I believe. Okay, so that's what that means. So let's check out number 8. Okay, this is the formula we're using. And the first number we're going to plug in is 1. So we're going to do 3 times 2 to the 1 minus 1. 1 minus 1 is 0, and 2 to the 0 is just 1. So we get 3. Then we're going to plug in the next number, 2 minus 1. Let's see, that'll be 6. Then we're going to plug in the next number. That's going to give us 12. Then we're going to plug in the next number. That's going to give us 24. That was a 12. And then we're going to plug in the next number, which I believe is going to give us 48. Yep, that looks right. And we are going to end with 6. That is the last thing we're plugging in. And I think we get 96. Okay, so when we plug those all in, this is the list of numbers we get. And then sigma means add them up. So I'm going to grab a calculator to do this one. It's hard to do in my head. Plus 24, plus 12, plus 6, plus 3. If I did that correctly, 189. Okay, so that is sigma notation. On any of these, if you have trouble remembering it, go back and look at your notes from that section and the work that we did. You should be able to find some more problems if you need to see some more. All right, we want to find the sum of all of these series. So we're going to be using one of the sum formulas that are on the top of the page. Now, which one we use depends on if we have an arithmetic or a geometric series, and if it's infinite or not. So that's what we need to figure out. So let's check out number 9. It is clearly finite because it has an end right here. Okay, it's not going on forever. So we want to see what kind of series this is. So as I look at the pattern between here, it looks like I am subtracting 9 over and over. So this is an arithmetic series. So the sum for an arithmetic series is n over 2 a1 plus an. All right. So the first thing we need to know is n. How many terms are there? We actually don't know. I'm just going to leave that blank for now. But we do know the first term, it's 54, and the last term is negative 18. So we need to find n. So we can use, oh yeah, I remember doing this. We can use the other formula, okay? Remember the formula for the nth term? We're going to use that to find out what n is. So an, that's our last term, is negative 18. A1 is 54. We don't know what n is, so just n minus 1. And then our common difference is negative 9. Okay, so I'm going to start by subtracting 54 from both sides. That gives me negative 72 equals n minus 1 times negative 9. I'm going to divide both sides by negative 9. I apologize for my handwriting. It's hard to write with. It's going to give us 8. And then finally, when we add 1 to both sides, that gives us n equals 9. So there are 9 terms in this series. So we'll go back to the other formula, plug in that 9 that we needed, and then go to our calculator. So 54 plus negative 18 times 9 divided by 2 is 162. That's our answer. Okay. We're going to do a similar thing on number 10. We need to use a sum formula. This is clearly a finite one. It ends. Okay. So we can't use the infinite formula. And we need to see what kind of series we're working with. So the pattern, it looks like we are multiplying by 3. That does not look like a 3, but we are. Okay, we're multiplying by 3 over and over again. So this is a geometric series. So the formula for a geometric series is a1, 1 minus r to the n over 1 minus r. All right, let's find out what we know. We can see the a1 is 5. 1 minus r, we just said was 3. Oh, and again, we don't know n. I'll have to come back to that. Okay, so we got to find that n. So to do that, we're going to use the other formula for geometric. The other formula is an equals a1 to the times r to the n minus 1. So our last term is 3, 6, 4, 5. Our first term is 5. Common ratio is 3, and n is what we're trying to find. All right, so I'm going to start solving this by dividing both sides by 5. So I get 729 equals 3 to the n minus 1. And now I would really like to bring that n minus 1 down in front. Hopefully you guys remember that to bring things down in front, we take the log or the natural log, and then we're able to bring that down in front. So we get the natural log. Let me write that again so you can actually read it. The natural log of 729 is n minus 1 times the natural log of 3. Now I'm going to take the natural log of 729 divided by the natural log of 3, and that gives me 6. And then my last step is to add 1 to both sides, so n is 7. So we'll come back over to that sum formula we were working with. Now that we know that n is 7, plug it in there, and now we can go to the calculator. So I'm starting with the numerator, 1 minus 3 to the 7th. I have to divide that by the denominator, 1 minus 3, that's just negative 2. And then I'm going to multiply that by 5. So my final answer is 5, 4, 6, 5. All right, let's check out number 11. Number 11 is different. This is a sum, that's what sigma means. We start with plugging in 1, and notice we're going to infinity. So this is an infinite series. So the infinite series formula is a1 over 1 minus r. That's the formula we have to use. Now, remember, we can only use this if our r, our common ratio, is between 1 and negative 1. If we look over here, our common ratio is 3. Okay, the base is always going to be that common ratio. That does not work. So this series does not exist. It's not possible to do, so you're going to actually say does not exist or no solution or something like that. All right, let's check out this last one. Again, this dot, dot, dot means this keeps going on forever. So this is an infinite series. So the formula that we have is a1 over 1 minus r. Again, this formula only works if r is between 1 and negative 1. So we need to check this out and see what the common ratio is. And it looks like we are multiplying by a third. So our common ratio is within the bounds that we need. So we can use the formula. A1 is 1, and we have 1 minus a third. If you're doing this in your calculator, you're going to need to toss that in parentheses. And when we do that, we get 1.5 for our answer. Okay. We will check out the last few problems in the last video.